This is Mrs. Schaefer. I just wanted to talk to you about the discussion quiz for 5.05, give you some helps and some guidance as you go through to complete this assignment. So the first thing you want to do is log into your physical science course and then click on content. This is found in Unit 3 under the periodic tables for chapters 4 and 5. Then you want to go into the Chapter 5 elements and down to the 5.05 elements and compounds. When you click on that, one of the things you will see is this discussion quiz. There is the ability to click on and preview this quiz ahead of time so that you can prepare and use your notes to help you out. The material will be covered in your Class Connect sessions, but you can also review in the course and on the word wall. You'll see that there are definitions here, and then definitions here, and then there's some videos along here, and then below where I've snipped this, there is also some additional resources, and you can find this video. You can click right here. See how it has that square with a large thing? You can click right there and it will open it up on a new tab in your browser. Otherwise, it will, when you click play, it will, or click on it anywhere, it will play right there. And it's a pretty small thing. So I recommend that you use this right there. Push your mouse over it and then click it so that it opens it up in a new tab. But you can see plenty of definitions and pictures and ideas and things that we've used in class. This is something we covered in class 2, where we talked about how atoms and compounds are different. So atoms are atoms of different elements can combine to form molecules and compounds. So one type of substance that we can create, or matter that we label, is called an element. It means that it's all the same atom in the sample. Whatever the sample is, it's all the same. In this case, this is the R atom. Each one of these is the R atom. They're all the same in this box that's giving us our sample size. So this is an element. We also talked about this box over here, how these are not only elements. We have the atom T, which could be an element. We also have the R, that's representing the symbol for a element from the periodic table, and then S, capital S, lowercase q. The S, capital S, next to a lowercase letter says those two go together. So right here is my example of my element SQ and my element R. So I have T from the periodic table, R, and SQ. But they're all mixed here together, so this is not an element. There are several atoms and there are some compounds here. A compound is a substance that is composed of two or more elements that are chemically bonded with a fixed ratio. And we see one square, one circle. There's a chemical bond between them, holding them together. There's no chemical bonds holding this one together. It's all by itself. T by itself, R by itself here. Here's another example of two of the same type of atom that are bonded together. There's a molecule of SQ and SQ, making it SQ with the subscript 2, saying that they're bonded together. The big thing there is, are they bonded together? So R is not bonded to anything. This T is not bonded to anything. But right here, this Q and R, they're touching each other. They are chemically bonded together. All right, so let's look at this, some real examples. So in our SQ squared right here, this could just be like oxygen. Oxygen is an element, and they are the same atoms bonded together. There are some atoms that prefer to be bonded together. It makes them more stable. It's just the way we find them more in nature. Those are called diatomic molecules. Oxygen and hydrogen are an example of them. Same atom, but they're bonded together. You can see that chemical bond. They're touching each other. Another example that we could use to represent our capital R, capital S, lowercase q, right here, this compound could be silver chloride. One silver is bonded with one chlorine atom. We can see those bonds right there. And that makes a liquid substance that you could look at. That's different than just silver by itself, which would be an element. So here's a picture of silver. It has the symbol Ag. There's the silver atom, and here is a silver atom right there connected to a chloride atom. That's Cl. So that's an example in real life of what we did here on the paper. So we can have diagrams that we can draw ourselves, or we can go out and get molecules showing the bonding patterns between them. So that's showing that chemical bond right there, connecting them. That's what that looks like. Weights. But that's how we draw the bonds, by connecting a line between them. From there, what we can do is now check our understanding. O2 is best described as what? Is it an element, a compound, or a mixture? AgCl is best described as an element, a compound, or a mixture. Oh, so we just talked about elements and compounds. One of the things we haven't talked about recently is the mixtures. So let's review that really quick before we answer those questions. This is from Unit 1 when we talked about how to categorize matter. And remember that we had this pure substance and mixtures. And there's some examples down here of them in our flow chart. We've already talked about elements and compounds, that they are pure substances, but we haven't reviewed recently mixture. So let's look at that real quick. Here's another picture of elements and compounds, just so you can see them. Remember that elements and compounds cannot be separated physically. That is the reason that they're on this side of the chart, is this elements and compounds cannot be separated by physical means. Well, how is that different from a mixture? Well, a mixture can be separated physically. It might not be easy, but it can be done physically. And here's some examples here of a mixture, like M&Ms. We can separate them out. They come to us as a mixture, and then we can separate them out by color. Here's another example of how this can look using just different balls for different colors. And you'll notice the difference between the two, heterogeneous and homogeneous. That was on our chart. Heterogeneous means that the mixture is not even. We can easily tell the pieces from one another, just like in this trail mix. We can easily pick out the M&M from the almond. But in this picture over here on the right, this is going to be harder to separate out. the lemon juice from the water and the sugar. So this is a homogeneous mixture in the sense it's all mixed together. It will be very hard for us to separate the particles. We can still separate it by physical means. We can boil off some of these and do some straining and some chemical tests on it. And that's why it's still called a mixture. All right, so now that we have gone through and reviewed this idea between pure substances, which cannot be separated by physical means, and mixtures, which can be, and you'll see that sugar water is down here on our homogeneous mixture. Lemonade, if depending if there's no pulp in it, would be a homogeneous mixture also. And then there's some other examples here of wood and rocks and steel that is heterogeneous mixture. And the big thing between a mixture and a compound or element would be these bonds. So in my example here, there's no bonds between the peanut and the M&M. But this whole square here, if I used this, you can see there are parts that have chemical bonds in them. So this would be a good example of a mixture. SQR3, which is right here, and TSQ, they have chemical bonds between them, but they're all mixed in the same container. This outline is our container. It's kind of like this right there. Well, hopefully that helps you as you go through now and answer the questions about oxygen and AgCl. Are they elements, compounds, or mixtures? Okay, and then you're given some pictures and asked to identify them. So here is something like what we saw earlier. So is this picture right here a pure substance or a mixture? And is it a pure substance made of compounds, a pure substance made of element, a mixture made of different compounds, and a mixture made of different elements? So the difference is you got to understand what a mixture is, a pure substance is, an element, and a compound. Same with this question. You're working on that idea. Which one is a pure substance? Which one is a mixture? Which one is a compound? Which one is an element? So use all of your resources that we've talked about to determine if something is a mixture or a pure substance, and then what are each of these items representing. That leads us to our final application, the essay question. That's where we're going to apply everything we learned so we can use those helps. What's the difference between an element and a compound? And give an example. Use this information to help you. Give your definition. Be sure to label clearly which is an element, which is a compound, and then give some samples or examples. You can use all the information in the class, in the textbook, and on the word wall to help you out. Good luck. Work hard. I know you can do it. If you have any questions, please let me know. Have a great day, and we will see you next time.